All right, so we have our question here. All right, standard normal distribution. Okay, Z represents the standardization. It's been standardized for you. N represents normal distribution. Zero represents the mean. One represents the standard deviation. So, colleagues, in this question, everything has been standardized for you. Okay, that's the good thing. Everything has been standardized for you. So it's just a matter of reading from the tables, the values. Okay. So we start with our first one here. P, a probability that Z is less than or equal to 3.10. How do we read this from the table? Here's the table. What value was it again? 3.10. Someone to tell us how we read this on the table. Hey, we've already forgotten, colleagues. Who was the one who told us in the previous question how to read from the table? Have they been logged out? Oh, okay, okay, okay. No, so I can. They are learning through you. Yes, we start with the column. You're right, sir. Mm-hmm. Yes. The last number represents the last digit in these decimal places. Okay. This last number, last digit for these decimal places. Mm. Zero. Usually, with this type of questions, 3.120. Yes. So it's good you raised that question. So usually with this type of questions, you always round up to two decimal places because the table can only accommodate two decimal places. So you always round off to two decimal places. Numbers with greater than two decimal places, you won't be able to read. So if that one 3.120, that zero has to be ignored. If it was a greater number, then you round off to two decimal places. Okay. It's 3.125, round off becomes 3.13. Then, yes, yes. Even the time you be, in case there are situations where you're standardizing, you find you might get four decimal places or more. Always bring answer back to two that you can read. Okay, so this is our probability here. Okay, this is where these two intersect. So here, probability is 0.9990, 99.9%. Okay, we go to the next question. Z greater than negative 0.27. Yes, colleagues? Z greater than negative 0.27. Let me write it here. Okay, Z greater than negative 0.27 here. Yes, colleagues, how do we get our probability? So this Z here at this bottom here, think of it as a negative 0.27. The area in blue represents less than negative 0.27. The area in white represents greater than negative 0.27. So colleagues, how do we get this one? Remember, it's okay to be wrong in your explanation. At least you will learn from that error that you've made. Mm-hmm. Mm-hmm. Or equal to. Just ignore it. There's nothing special if it's equal to or just by itself. Okay? There's nothing special that happens. Yes. That's just a way of examiners trying to trick you. So, madam, how do we find this probability in white? Yes. Yes. With probability in white minus probability. Ah, no, no, no. Wait, wait. Hold on, madam. Hold on. We are adding it. The probability in, yes, the equal to, yes. So the probability in blue, how do we represent it? In terms of this notation here, PZ, how do we represent it? Less than, yes, less than or equal to negative zero point 0.3. Then the area in white, yes. Okay, remember colleagues, it's always less than plus greater than equals to 1. Yes. Less than blue, great. Less than, yeah, blue greater than white area and equals to 1. Okay, so the table can only give us the blue area. So let's read our blue area. Oh, why have I put 0.3 here? Ish, 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 ish. I bet some people got confused, like, how's that 0.3? Appeared from nowhere. Oh, yeah, you can also think of rounded dove. Yes. Okay. How do we read on our table? Our value is negative 0.27, 0.27. It's negative, sir. It's negative, yes. And how do we read it off this table? Where do we look first and then where do we look second? Yes. For, yes. Okay, yes, we go to the first row. Since we've got a 7 here, so how was I dragged? Oh, so we look for 7 here. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8 steps. So here, 1, 2, 3, 4, 5, 6, 7, 8. Yes, so this is where our values intersect. Okay, 0.3936. So 0.3936 plus our probability that z is greater than negative 0.27 equals 1. Yes. So in order to get our probability here, we just take the 0.3936 over the equal sign. So it becomes 1 minus 0.3936. Yes, 1 minus 0.3936. 606. Okay. Yeah, here you can leave it to 4 decimal places, 3 decimal places. Okay. When even two, sir, two is okay. So to maintain consistency, let's leave it to 2. So 0.61 then, so that people are not getting confused. How come here there are 4, but there are 2? So we'll keep everything to 2 decimal places. Yes. Just that in these probabilities here inside here, as you can see, there are to 4 decimal places. So yes, Just ask your question again. If we are given a graph like this to find, or so you're talking about if this white part was the shaded part, uh-huh, and the unshaded part is greater than, is great. Yes, for us to find this part in white, we need to first get this shaded part first, the value of the shaded part. Then subtract it from 1. Then that will give us this white area here, the unshaded part, yes. Because in the question, the sign was pointing to the right. So, yes. Okay, the next part, we have the letter between two numbers. So, as I said, the greater probability minus the smaller probability. So Z less than 2.63, which is the greater one, minus P Z less than or equal to negative 1.45. Okay, you put the greater one first, then subtract it from the lesser one. So we come to our graph, we get our values. First, we start with 2.63. Yes, the first two digits, you look for them in the column 2.6 here. The last digit, this 3, on top here, 0.03. And where they intersect, that is your value. So they intersect at this one here, 0.9957. Minus, then we go to whatever again, less than negative 1.5. 1.45. Mm-hmm. Yes. Mm-hmm. Mm-hmm. Since it's negative, we go to the negative table. Have you seen this one, the negative part? 1.45. So the first two digits, negative 1.4 here. The last digit, 5 here. So where they intersect, 0.0735. 0.073. Eh? Did I overread it? 0.073. Okay. Yes, so you subtract 0.9957 minus 0.0735. 0.92. Yes.